All right, so I'm going to go over some of the test review that y'all were supposed to do in class today, just to give you a little extra review and a little extra guidance, hoping that this will help you get the assignment complete and prepare you for the test. So question number 1 was one of the required questions. That one you can just do by looking at your colored sheet or by going through your notes. So I'm not going to go through that one. Remember that this is all stuff that you need to know. So you need to know that by heart. You need to memorize it, how to find each and every one of those things. So if you need to study something, that is what you need to study. So looking at number 2, we're looking for the vertical asymptote and the horizontal asymptote. So I'm going to do the horizontal asymptote first. So what we're doing is we're looking for the degree of the top and the bottom. So the degree of the top for this one, there's no x, so the degree is 0. The degree on the bottom is going to be 1, because this is x to the first power. So whenever that happens, whenever it's bottom heavy, whenever the top is less than the bottom for the degree, then our horizontal asymptote is going to be y equals 0. All right, let's just keep on trend with going for horizontal asymptote. So looking for number 3, I'm going to rewrite this denominator because we want our x to be first. So I'm going to write it as negative x plus 5. So the degree of the top for this one is going to be 1. The degree of the bottom is also 1 because we just have 1x. And so what we're going to do is take the ratio of the leading coefficients. So on top we have a 2, and on the bottom we have a negative 1. So our horizontal asymptote would be y equals negative 2. Okay, so whenever you have the same degree on the top and the bottom, you take the ratio of the leading coefficients. Make sure you're careful about the leading coefficients. All right, for number 4, the degree of the top is 1 and the degree of the bottom is 2. So we're bottom heavy again, which means our horizontal asymptote is y equals 0. All right, and then the last one. So our top, the degree is 3, the bottom is 1. So now we're top heavy. So whenever we're top heavy, we're going to be none. We would have no horizontal asymptote whenever the top is bigger than the bottom. Okay, so looking at vertical asymptotes now. So vertical asymptotes are going to be whatever makes the denominator 0 and doesn't cancel. So nothing would cancel for number 2 if we factored. So I'm just going to take that x plus 5 and set it equal to 0. Solve for x, so I'd subtract 5 from both sides. So x would equal negative 5. And something super big to remember is that a vertical asymptote is x equals, horizontal asymptote is y equals. You will not get any credit for putting 0 or just putting negative 5 because you need to know that it's an equation. All right, for number 3, set the denominator equal to 0. We have 5 minus x equals 0. If we solve that for x, x would just equal 5. All right, number 4, set the denominator equal to 0, but we need to factor first and see if anything cancels. So on the top, we can't factor, so it's just going to be x plus 1. On the bottom, we have a difference of squares, so that would be x plus 2, x minus 2. So nothing cancels here. So if nothing cancels, that means we don't have a whole. But we have 2 things in the denominator, so we're going to have 2 vertical asymptotes. So if we set them both equal to 0, we have x plus 2 equals 0, x minus 2 equals 0. We solve those for x, so we get x equals negative 2, x equals 2. Okay? And then for the last one, set the denominator equal to 0, x minus 4 equals 0, so x would equal 4. Okay, so I feel like the biggest thing to remember is that vertical asymptote is your denominator, horizontal asymptote is the degrees. You need to remember what each one means. So if we look at number 6, that one is state the horizontal asymptote. So we're looking for degrees. So if we look at the degree of the top here, the degree of the top is going to be 2. The degree of the bottom is also 2. So our ratio is what we use for this one. So y equals, you have to have the y equals 4/3. Okay? All right, and then for the domain of number 7. So it's good to remember that for our domain, we take out our vertical asymptote and the x value of the whole. Those are both values that make the denominator 0, which will make our function undefined, which we don't want. So whenever you're looking, you don't have to find the whole, you don't have to find the vertical asymptote. All you need to do, if it's just finding the domain, is take that denominator, set it equal to 0, and solve for x. And that's what can't be in your domain. So if we factor this isn't 1, so we need to multiply those together. We get -6. What multiplies to -6 and adds to -5? Be -6 and +1. So remember, we replace that. We can't use the shortcut because a is not 1. All right, and then we group the first two together. Our GCF would be 2x, x minus 3. GCF for these two would be +1, x minus 3. So our two factors would be 2x plus 1, x minus 3. So set both of those factors equal to 0, and those are both of the numbers that x can't equal. So we can't have x equaling -1/2, and x can't equal 3. Okay, so just whatever the denominator, whatever is going to make it 0, whatever x value will cause our function to be undefined can't be in the domain. So I'm going to write this in interval notation. So -∞ is where we start. -1/2 is smaller than 3, so that would come first. Union, -1/2 to 3, union 3 to infinity. All right, and then from there, that is it. I don't know what I was trying to say. That is your final answer. So remember, these numbers right here should be the same, and these should be the same. And those should be the numbers that you're trying to take out of your domain. All right, let's look at all of this together with a graph. So these are going to be like the biggest questions. Like this covers everything that we talked about for the first couple days of this unit. So remember, we go in order. Our first step is our horizontal asymptote, just like we did on that other page. So if we look, the degree of the top is 2, the degree of the bottom is 2. So our horizontal asymptote is going to be the ratio of the leading coefficients. So that would be y equals 3/1, which would be y equals 3. All right, I'm going to go ahead and just put that on my graph so I have it. Y equals 3, that's a horizontal line at y equals 3. All right, so second step would be to figure out our whole. So this is where we have to factor and see if anything is going to cancel out. So I'm not going to go through the steps of factoring again. I would pause the video and factor on your own and check to see if you got the same thing that I did. But when you factor this, you would get 3x minus 1 times x plus 3 over x minus 5 times x plus 3. So what we're looking for is, do any of our factors cancel? Do we have anything on the top and the bottom? So if I look at the top and the bottom, I have x plus 3 on the top and the bottom. So that factor that cancels, that tells me the x value of the whole. So I'm going to set that factor equal to 0 and solve for x. So x equals -3 for our whole. All right, and then whatever we have left, in this case, it would be 3x minus 1 over x minus 5. We want to plug that -3 into that function to see what our y value is going to be. So I'm going to plug -3 in everywhere there's an x to figure out my y value. So we would end up with -10 over -8. And then simplify that, it would simplify to 5 over 4. And you will have a calculator for these types of questions. All right, I'm going to go ahead and put my whole on my graph too. Remember that your whole needs to be an open circle, and it's going to be at 5 over 4, which is a little over 1. All right, third step is going to be find our vertical asymptote. So number 3, whatever's left in the denominator, that's our vertical asymptote. So x minus 5 equals 0. So x equals 5. All right. So then the rest of it, you can kind of do in any order. It's kind of up to you, however you want to work through it. Now that we have all of our discontinuities, I like to go ahead and do domain and range. So for our domain, x can't equal whatever makes the denominator 0, which in this case would be our whole, just the x value at -3, and our vertical asymptote at 5. So we need to take those two numbers out of our domain. And then for our range, y can't equal, again, any of our discontinuities. So it can't equal the horizontal asymptote, and it cannot equal the y value of the whole, which would be 5 over 4. Okay, so knowing that is like the biggest part of this, and then what you want to do is just write it in interval notation. So we write it from least to greatest. We start at -infinity, go to -3, -3 to 5, 5 to infinity. All right, and then for our range, we would do -infinity to 5 over 4, 5 over 4 to 3, union 3 to infinity. Okay, so just taking those values out, whatever we wrote over here, and I would just keep this list as you go. That way you don't forget. So maybe make a note to yourself how to find domain, how to find range. Memorize that kind of thing. Write it on your test as soon as you get your paper. All right, now x-intercept, y-intercept. So x-intercept is where you take whatever is in the top of your function. So this 3x minus 1, we'd set that equal to 0. So 3x minus 1 equals 0, and solve for x. Okay, so our x-intercept for that one would be 1/3. And remember that the 0 comes second. And then for our y-intercept, that's going to be whatever we get when we plug 0 in for all of our x's. You can plug it into the original function, or you can plug it into the simplified. It doesn't really matter. You'll get the same thing. So I'm going to plug it into the the simplified one. So everywhere there's an x, I'm going to put 0 instead. All right, 3 times 0 is 0, minus 1, and then 0 minus 5 is negative. So our y-intercept would be 0, 1/5. All right, so those are points that you also would need to put on your graph. So I'm going to go ahead and put 1/3, or I'm going to put 0, 1/5 on the graph, which is a little bit bigger than 0. And then for the x-intercept, 1/3, 0. So it's going to be kind of in that same region. And then I forgot to put my vertical asymptote on the graph. So x equals 5. So we count 1, 2, 3, 4, 5 on the x-axis. and you should have a vertical asymptote there. Okay, so now we can just sketch the rest of the graph. You don't need to know any other points than the ones that you found. So I'm going to sketch and just kind of know the shape of the graph. We're approaching those asymptotes, but we're not touching them. And remember that these come in two parts, and this will always be in the opposite section. So like flipping over that middle point. So we don't know anything over there. I'm not grading you on that. I just want you to know that there's going to be something over there. So I'm grading on it if it's there, but not like how perfect it's graphed. All right, so last two things, increasing and decreasing. So if I'm going to take a highlighter, and if I were to trace my graph from left to right, I always start on the left side. I'm tracing these arrows, and as I trace it, I'm going down. So I'm going down from arrow to arrow. And if I pop back up to this next section, I'm still just tracing down. So this entire graph is decreasing. So we will have no increasing, so we'd put none. And then we would just take our domain and write it in the decreasing line. So your domain should always match your increasing or decreasing. And the graphs we work with in this class, you're only ever going to have increasing or it's going to be decreasing. It's never going to be both. All right, end behavior. So this is where some people get stuck. End behavior for this one. We have a horizontal asymptote. So whenever you have one of those, as we go to infinity, our graph is leveling off and approaching that asymptote. It's not going to cross it. It's approaching it. So the asymptote is at 3. So our graph is approaching 3. So as x goes to infinity, our graph approaches 3. As x goes to negative infinity, the graph is doing the exact same thing just from the bottom. So now it's leveling off, still approaching 3, and it's not going to go past that. So we would go negative infinity to 3. So if you have a horizontal asymptote, these should be your horizontal asymptote. Okay, it's a lot really fast. So let's try one more. And I highly encourage you to do number 10 on your own. All right, so this one's a little bit more straightforward because we don't have to really factor anything. Our first step is still going to be our horizontal asymptote. So the degree of the top is 0. There's no x up top. And the degree of the bottom is 1. So we're just going to, so that means our horizontal asymptote is y equals 0. It's bottom heavy. Bottom heavy means 0. Second step would be our hole. So this is where you kind of think, I can't factor, nothing's going to cancel out, so that means I have no hole. Third step is vertical asymptote. What will make my denominator 0? So we're going to set the denominator equal to 0, x plus 5 equals 0, and solve for x. So that would just be x equals negative 5. All right, let's do domain and range next. So let's take out our discontinuities. X can't equal negative 5 because of that vertical asymptote. Y can't equal 0 because of the horizontal asymptote. So there's only one number to take out because we don't have a hole this time. So we would write this negative infinity to negative 5 union negative 5 to infinity. The range would be negative infinity to 0 union 0 to infinity. All right, x-intercept, y-intercept. X-intercept, we set the numerator equal to 0 and solve for x. So if I set the numerator equal to 0, 3 equals 0 is not a true statement. If you just have a number up top and your horizontal asymptote is y equals 0, then you will have no x-intercept. Okay? Your y-intercept, plug 0 in for x. Everywhere there's an x. So I'm just going to do that over here in purple. 3 over 0 plus 5 equals 3 over 5. So our y-intercept would be 0, 3 over 5. All right, now I just need to graph everything. So I'm going to go ahead and put 0, 3 over 5 on there. It's a little bit smaller than 1. We have no x-intercept. I'll put my vertical asymptote at -5. 1, 2, 3, 4, 5. My horizontal asymptote is at y equals 0. So we'll have a horizontal line there. And we have no other points to graph. So we're really only going off our asymptotes and one extra point. So now we're going to just get our shape of the graph so we can figure out increasing or decreasing. So we're going to have it kind of approaching. And then this section, we're just going to sketch because we know it needs to be in the opposite section of that one. All right, and let's trace. So let's see if we're increasing or decreasing. Start on the very left side of your graph, that left arrow. We're going to be decreasing, pop back up, and we're decreasing again. So we're decreasing again for the whole graph. So we're going to take our domain and write it on the decreasing line. So write negative infinity to -5, union -5 to infinity. Increasing would be none. And then for end behavior, so we know these are going to be infinity and negative infinity. So let's go look at our graph, even though you could do this without looking at the graph. So as x goes to infinity, this arrow is approaching our horizontal asymptote. So it's approaching y equals 0. So on the right half, we're approaching 0, which, like I said, if you have a horizontal asymptote, these should both be 0. Okay, and you can see on this side, this graph is leveling off and it's approaching 0. It's not going to go past it. It's not going to infinity because it's leveling off. Okay? All right, I really suggest you do number 10. It will be extra credit if you do it. You need to factor, and this one's going to have a hole, and it's going to have no vertical asymptote and no horizontal asymptote. We did a bunch of examples of those in the notes, so make sure if you're stuck, you can go look there. All right, number 11 is one of those weird questions that we've seen from the SOLs, so it will be on your test. It's just kind of a different way to find, like, to write your domain. So what we're going to do is we're going to find our domain first. So remember, all you have to worry about when you're looking for your domain is factoring the denominator, setting it equal to 0. So x squared plus 5x minus 6 equals 0. So x plus 6, x minus 1 equals 0. So x can't equal -6, x can't equal 1, because they will cause the denominator to equal 0. So then this is where the weird notation comes in. So our domain is x. We're going to start at negative infinity just like we always do, but now we're going to use inequality symbols, and we're still doing it from least to greatest. And then we'll start up again at -6 and go to -2. And then start up again. I'm going to just go to the next level, -2, and go to infinity. So this is the kind of thing that you'll see that will be like multiple choice. So if you see this question, just really look for, like, find your domain and then look for these numbers and make sure they match what you said x can't equal, and you should be good to go. All right, now solving equations. So for number 13, this would be one where we want to find our restricted domain first, and then we're going to cross multiply. So remember, to find your restricted domain, you set your denominators equal to 0 and solve for x. So we'd have x can't equal -2. and x can't equal 9 over 8. Okay, so make sure you check your final answers because something might not be right. So we're going to cross multiply. So I'm going to do x times x plus 2 equals, and then 1 times x, 8x minus 9, which would just be 8x minus 9. All right, so we have to multiply the left side, so distribute that x in. We'd have x squared plus 2x equals 8x minus 9. So this x squared right here hints that you have to factor. So we're going to get everything to one side so that we can factor. And I'm just doing that all in one step. So combine like terms, we have x squared, 2x minus 8x is negative 6x, and then plus 9 equals 0. Okay, then we factor that. So in this case, it would be x minus 3 equals 0. So they're both the same. They're both going to give you x equals 3. So compare that to our restricted domain. Can't equal negative 2. 3 is not negative 2. 3 is not 9 over 8. So we're good to go. All right, so whenever you see two fractions being equal to each other, you can try to get a least common denominator first if you want to, but just cross multiplying will be an easy way to solve. So now number 15. So this is one, because we have this plus in between and we have three different pieces of this equation, then we have to find a least common denominator to be able to solve. So first thing I'm going to do is find my least common denominator, and then we'll find our restricted domain. So our LCD, in this case, you're looking for what they all already have in common. So this one technically has a 1. So both of these already have an x plus 1, and then multiplying by 1 isn't going to change anything. So we're just going to multiply each fraction by x plus 1. And then when you find the restricted domain, you're just taking that least common denominator, setting it equal to 0, and solving for x. So x can't equal negative 1. All right, so let's multiply by our least common denominator. So x plus 1, x plus 1, x plus 1. And we're going to see if anything cancels. And that's kind of the whole point of this. We want all of our fractions to cancel out. We don't want any left. So I have x plus 1 on the top and the bottom. So all I have left is a 4x. X plus 1 on the top and the bottom. So I have x plus 5. And then on the right side, nothing is going to cancel out. So we're just going to have 5x times x plus 1. All right, so we're going to combine like terms, distribute, and then solve for x. So on the left side, 4x plus 5x, 4x plus x would give you 5x plus 5 equals, to distribute this in, so we have 5x squared plus 5x. I want to get everything to one side. Remember that when you have something that's squared, usually means you're going to have to factor. So I'm going to subtract 5x from both sides, minus 5x. Usually means you have to factor. So I'm going to subtract 5x minus 5 minus 5x minus 5. So we'd have 5x squared. These cancel out. Minus 5 equals 0. So you could technically solve this one without factoring, but I'm going to go ahead and factor. So I'm going to factor out a GCF of 5, and then factor what's left in the parentheses. So 5 times x plus 1, x minus 1. And then set them both equal to 0 and solve for x. A lot of people ask about this GCF right here. It doesn't change anything. It's not going to change a solution. So we're just looking at x plus 1 equals 0, x minus 1 equals 0. So x equals negative 1, x equals 1. Let's check against our restricted domain. So if we look at this one, our restricted domain says we can't equal negative 1, but we got that as a solution. So we need to make sure to cross that off, and our only solution would be x equals 1. All right, number 17. I'm going to help you set this one up, and then I want you to solve it on your own. So I'm going to factor the denominator first to find my LCD. So what we need to do is factor this. That would be x minus 3, x plus 2. So basically, whenever you have to factor, that's probably going to be your denominator. So x minus 3, x plus 2. This one already has an x minus 3. This one has an x plus 2, so it takes care of all of those. And then our restricted domain, set them both equal to 0 and solve for x. So x can't equal 3. X can't equal negative 2. All right, so go through and multiply all of these fractions by your LCD and solve, and you should get x equals 5. Okay, so I'm giving you the answer because I want you to go through and solve and know that you did it correctly. All right, now on to the next page. We have some of our random questions. So writing these word problems that we have, we need to be able to write them as an equation. So remember that when you see ratio, ratio means you're dividing. Okay, so 5 less than a number is what's going to be on top because this 2 splits our ratio. So 5 less than a number, remember that switches it around. So it's going to be x minus 5. Less than means subtraction. Than means you flip. And then 9 more than the number. So the same number is x plus 9 because we have more than now. And the is means equals, so it equals 2 over 3. And then that you would just solve by cross multiplying. So make sure you find your restricted domain and then cross multiply. I'm going to go ahead and give you the answer again, but I need you to solve it, so you won't get full credit if it's not solved through. So x would equal 33 for this one. Okay, so go through, solve this question so that you can get full credit, but I want you to know that you got it correct. All right, number 19. So these are the weird ones where we have to get y by itself so that we can even see what our equation looks like. So I'm going to go ahead and subtract 1 because that 1 doesn't have a y. So 3xy minus 5y equals x minus 1. So now that everything on the left side has a y, we're just going to factor a y out. So we'd be left with 3x minus 5 equals x minus 1. So then we need to divide both sides by that 3x minus 5. So we end up with x minus 1 over 3x minus 5. All right, and the whole question is asking, what is the domain? We now have a rational function. Our domain can't have anything that makes this denominator 0. So set the denominator equal to 0 and solve for x. So we'd have 3x equals 5, x equals 5 over 3. And then we have to write that in interval notation. So we would write it as negative infinity to 5 over 3 union 5 over 3 to infinity. All right, I would absolutely do number 2 also. Number 20 also. You'll get extra credit. And then for the review questions, I'll go through a little bit of them. I'm not going to go through them that in depth. So if you're stating the zeros from your graph, I think the biggest mistake I've seen people do or people make is flipping the sign. So if it asks for zeros, you're just literally looking at your graph and telling me where does it cross. So it crosses at x equals negative 4, x equals 1, and x equals 3. Okay, so those are the exact spots where they cross. And what I want you to do is tell me what behavior is happening. So multiplicity, we have a wiggle here, so that's going to be 3. So the multiplicity would be 3 for a negative 4. Here, we have a bounce. That would be a multiplicity of 2. And here we just cross straight through, so we have a multiplicity of 1. All right, so this one, you need to find your discriminant and then solve. I'm going to help you with the discriminant, not solving for it, but just kind of plugging everything in. So first thing we need to do is figure out, or we need to get everything on one side. So I'm going to do that. So our discriminant is b squared minus 4ac. So A, B, and C in that order. So plug those in. Remember, it's the numbers in front of x. It's not the number, or it's not the variable. So x is not included in this. Your discriminant should be 113. So I want to see you have plugged it in. So you should have something written on your paper that looks like this. And you fill those in. You do that work. So types of solutions. I'm going to write this. So your discriminant, if it's greater than 0, then you have 2 real solutions. If your discriminant is equal to 0, then you have 1 real solution. And if your discriminant is less than 0, then you have 2 imaginary solutions. Okay? This is really important to know for your test. You'll only have one review question like this, but highly recommend you look at this and study that. Remember that. So you tell me the types of solutions and then you solve. So I would use the quadratic formula. Remember, that's in your Unit 6 notes. Okay? And then last thing, or we have 2 more. Vertex axis of symmetry. Remember, vertex is this point right here. So that point would be -3, -6. Axis of symmetry is the x value of your vertex. It's that vertical line down the middle of your graph. So it's going to be x equals -3. And then your absolute minimum versus absolute maximum. So we have, this is the lowest point on our graph. So that would be an absolute minimum, and it would be your vertex. So -6 at x equals -3, and we'd have no maximum. All right, and then final thing for number 24, find the domain of a square root function. We can't have any negatives under the square root if we're trying to graph it. So what we have to do is take what's under the square root and set it greater than or equal to 0. So make sure it's a positive number. So solve for x. So x has to be greater than or equal to -1/2. And if you were writing that in interval notation, you would start at -1/2 and go to infinity. All right, so I know that was a lot really quickly, but hopefully this helps y'all to prepare for the test. Please, please, please study this stuff. Please go back and remember that colored sheet. Remember step by step what you need to do to find each part. And I wish